All right, so we're right on the first page of our review booklet here. This is Unit 1, and we call this kind of Steps to Success. You probably noticed last week during your digital overview that there's a little bit of everything in here, but there are 4 main concepts that we're going to review. The first one was problem-solving strategies. After that, we talked pretty briefly about sequences, but I think it's worth mentioning here. And then we talked about converting words to algebraic expressions. That's going to come in handy when we get into those word problems. And last but not least, we did some shape puzzles. And I bet some of you might think this one's a little familiar. So let's go back to the beginning of page 1. We'll do some notes together. Now, of course, my notes are not the only ones that you might have on there. If you have your own stuff to add, please do so. So our first problem-solving strategy is starting with reading. We have to read the problem, and sometimes we do that more carefully than other times. So let's go through this. Alejandro works at Corey's coffee shop after school on some days. A customer's order comes to $4.70. The customer hands Alejandro a $5 bill, so she gives the customer 30 cents in change. Because Alejandro loves math, favorite student right there, she begins to think about the different ways in which she could have given the customers 30 cents in change. So there's a lot of information in here, but really the question we're being asked to do is to say only quarters, dimes, and nickels. Try to find 4 different combinations that make 30 cents. And I believe you could make more than 4 combinations, but what this is going to entail is a little bit of guessing and checking to start if we don't have 4 combinations in mind already. What this comes down to is making a list, and it is a problem-solving strategy to list out our options. So one option might be 1 quarter and 1 nickel, because that's 25 cents plus 5 cents. And we get 30 cents, exactly what we want. Another combination might be 3 dimes, because that would be 10 cents 3 times over, or adding 10 to itself 3 times, and we get 30 cents again. So we've got 3 dimes, we've got 1 quarter, 1 nickel. We could have 6 nickels. That would be 6 times 5 cents, or 30 cents. And one more option, maybe let's mix it up a little bit. How about 2 dimes? So I might say, well, if I have 2 dimes, what else can that make? Well, 2 dimes is 2 times 10 cents, or 20 cents, leaving me with 10 cents left over that I have to use, and I can do that with 2 nickels. So if you ever get to a point where you're starting a list and you're stuck about where to go, try to make some possibilities. If you just kind of set up like, what if, you can answer the question, well, here's what it would be. All right, another problem where, again, reading is going to be helpful, and we're going to make a list. A list is generally a valuable strategy. So Timeless Toys builds tricycles and wagons. Oh, the good old days. The owner noticed that there are several ways a customer could place an order for 5 items. For example, the customer could order all tricycles, all wagons, or some combination of the two. So for the case of a 5-item order, we're going to list 3 different possible combinations and then list the total number of wheels. So combination 1, well, maybe they're just going to do all tricycles. So they have 5 tricycles. That means they've got 0 wagons. Now, to know how many wheels, well, a tricycle has 3 wheels, a wagon has 4 wheels. So 5 tricycles times 3 wheels is 15 total wheels. On the total flip side, they could have 0 tricycles and 5 wagons. So again, to find the total number of wheels, I take the number of wagons and multiply it by the number of wheels for each wagon, and I get 20 wheels. So the next combination, how about 1 tricycle and 4 wagons? That would give us a total of 5 items. Now I have to be a little bit more careful with my multiplication and my addition here. So this is, excuse me, let me erase that. Tried to write 5 again, but I don't have 5 tricycles. I've only got 1. So come on, eraser. There we go. We've got 1 tricycle with 3 wheels plus 4 wagons with 4 wheels each. So this is 3 wheels. This is 16 wheels for a grand total of 19. So not the only options out there, but a couple of them. Now, this question, if the customer ordered 5 items, so kind of same setup as before, but the order had a total of 17 wheels, this time we want to know how many wagons were ordered. So a list is a good way to do this. We've already got our list started. We just don't have the number of wheels that we want. So I could continue my list. This time maybe I'm going to turn it into a table. I'm going to do the number of tricycles, the number of wagons, and the number of wheels, and kind of continue this process, but now in a table form. So I know that some combinations that work, or I should say that don't work, so I'll try a different one. 2 tricycles and 3 wagons. Well, that's 2 tricycles with 3 wheels each, plus 3 wagons with 4 wheels each, which is 6 plus 12, or 18 wheels. So we're getting closer, but we're still not at that 17. So let's try one more combination here. Maybe this one will be it. Oops, we don't have 2 tricycles. We've got, excuse me, come on, eraser. There we go. Come on, there we go. We've got, not eraser, 3 tricycles with 3 wheels each and 2 wagons with 4 wheels each. So 9 wheels plus 8. Aha, that gives us our 17 wheels. So now our question, how many wagons were ordered? We would say 2 wagons were ordered. So remember, it's not only important to do the work, to show your work, but to answer the question. If we answered the question that wasn't asked well, we're not feeling too good. But this one, we're feeling great about. So ta-da. All right. So some problem solving strategies. Remember that if you don't know how to answer a question right away, that's not the end of the world. You can try a couple of things just like we did here. The next one, sequences. Sequences are patterns, lists of numbers. So in order to work with a sequence, you have to be able to work with patterns, and I think we know how to do that. So Martina and Karina each wrote a number pattern on a strip of paper for the other to figure out. How sweet. We want to find the next 2 numbers in each number pattern. So we first have to know what's going on. So Martina's pattern, she goes from 2 to 6, from 6 to 10, from 10 to 14. So now we want to know what happens if we keep following that same pattern. Well, okay, we can try a few things. How do I go from 2 to 6? Okay, I add 4. Does that work here? Is 6 plus 4 equal to 10? Yes, perfect. Okay, let's try it again. 10 plus 4, 14. All right, this looks like a pattern that's working here. So 14 plus 4, we get 18. 18 plus 4, we get 22. So we have figured out Martina's pattern. So for Karina's pattern, we're going to try the same thing. We've got this list of numbers, and we want to see what's happening between each number so that we can fill out the following 2 numbers. So it starts the same way. We've got 2 to 6. So I know I add 4 to go from 2 to 6. But when I add 4 to 6 this time, I'm supposed to get 18, but 6 plus 4 is 10. So that pattern that I was trying out isn't going to work. So I'm going to get rid of that. Well, let's try something else. How else can I get from 2 to 6? I could use a different operation and multiply by 3. 2 times 3 is 6. If I try that again, 6 times 3, is 18. It looks like we're on the right track now. So 18 times 3 turns out to be 54. So that must be the way to go here. So I can do 54 times 3, which is 162. And if I do 162 times 3, should I tell you what it is, or should I make you calculate it yourself? I'll tell you what it is. Look at me. 486. So a little bit of guessing and checking here. Emphasis on the checking, right? It's okay to guess, but you must check. So patterns, sequences, I think you've got what it takes. Our third concept, our words to algebraic expression. We saw that this is really helpful when we're getting into word problems. So we're translating the written expressions into algebraic expressions. So from words to math. So 3 divided by f. So we could write it a couple of ways. we could write 3 divided by f if we want to use kind of the notation from elementary school. But we don't often use this notation in high school. Instead, we use a ratio or a fraction form. So we say 3 divided by f, and it's always the number that's being divided is on top, and then the number that is being divided into it goes in the denominator. So these are the same exact thing here. Now the sum of 8 and r, sum indicates addition. So the sum of 8 and r is 8 plus r, or remember, addition can work both ways. These are the same exact thing, 8 plus r or r plus 8. W less than 15. So we know that there's subtraction involved. Less than or less is always subtraction. We know that there's subtraction involved. But remember, the order of the order of subtraction matters. So it says it's W less than 15. So that means we're taking 15 and we're getting W less than it. If I were to translate that into a different number, if I were to say 6 less than 15, well, that would be 15 minus 6, right? So it's the same thing here. We, instead of 15 minus 6, it's W less than 15, so we say 15 minus W. For more than M, more than meaning addition again. And with addition, the order doesn't matter. We saw that up above. So we could either write 4 plus M or M plus 4. With addition, we can reverse order. Now, it starts to get a little bit trickier here when we add more than one operation. So number 5 says 8 less than 2 times k. So we've got some subtraction going on and we've got some multiplication going on. Now, order of operations tells us multiplication is going to come first. This is 2 times k, and then it's going to be 8 less than that whole shebang. So 2 times k is 2k, and 8 less than it is going to be minus 8. So we can write it as 2k minus 8. Come on, buddy. Sorry, my 8's a little sloppy and it's bothering me. 8. Okay, so if we've got more than one operation, we just want to really read it very, very carefully. A couple more here. The product of 7 and p. Product refers to multiplication. It's the word for the end result. It's basically the equivalent of sum, but for multiplication. So this is 7p. Or really, we could do something like p times 7, but convention says that this is the way to go. And last, p divided by -3. Again, we know that the number that's being divided goes on the numerator. The number that is doing the dividing goes in the denominator. So the word algebraic expressions can seem pretty straightforward, but we have to pay attention to the details. All right, last shape puzzle here. I probably don't even need to do this video because a lot of you use this one for your video, but the key to solving your shape puzzles is to do the easiest one first. So when I mean easiest one, I mean looking for the puzzle that has the fewest mysteries here. And I see puzzle 1 here. You can just ignore this part where it says equation using letters. Just cross that out. And so we will say solve step 1 here. So 2 plus something is 7. That 2 plus something must be 5. So from this, we get that a diamond is equal to 5. And then what we can do is we get to take that diamond and replace it with 5 in all the other expressions. So this is kind of our first step here. Now our second step, well, I can take 5 and subtract something from it to get 1. That something is going to be 4. So my triangle is equal to 4. 4, 4, 4. And then we could use either one of these next 2 clues. It just depends on how you want to go. But if I use this top one, 4 plus 5 is equal to 9. So that means that my hexagon is equal to 9. And I can always double check. If I replace this with 9, 4 plus 9 is equal to 13. We live happily ever after. So again, with a shape puzzle, you kind of want to start with the easiest there, the most simple equation, and use it to fill it in as you go. All right, before you turn the page and get started on the practice, I need you to rate your understanding. This is going to give you an idea of things to study before you take your final next Wednesday. So for each category here, you're going to rate yourself. If you feel really, really awesome about it, you could teach somebody else. You're going to rate yourself a 5. If you're not feeling so good, you really, really need some help, you really need to focus on this, you're going to rate yourself a 1, and then anywhere in between. So get to work on your practice on the next page. You can work together or you can work alone. But either way, you've got something to work on. Have a terrific rest of your day, and I'll see you tomorrow.